All right, guys, welcome back. And in this video, we'll be talking about closures. So we started our discussion on the topic of closures during the last session that we had together. All right, so I hope to give you some practical um, use cases. All right, when we talk about closures. Okay, but before we do that, I would like to do a brief revision of some of the concepts that I think are crucial to understanding this concept of closures. All right, in JavaScript. Okay, so one of them is the idea that functions are first class citizens in JavaScript. All right. So always remember that you need to remember that functions are first class citizens in JavaScript. So what does this mean? All right. This is going to mean three things. Number one is that functions can be assigned to values or to variables. All right. Functions can be assigned to variables. And then number two, another interpretation of the statement functions are first class citizens would be that functions can be passed. Functions can be passed. So I'm going to bring this to another line. So let's break this line. All right. So I'm going to do it like this. Functions can be passed to other functions, or we could say a function can be passed into another function as an argument. All right. So that'll be the second interpretation to this statement. All right. Or interpretation of that statement. And then the last one would be that for a function can be returned, all right, from another function. All right. So this is what we mean when we say a function is a first class citizens. Okay. Is a first class citizen. Now, if you think about this, all right, these are stuff that we naturally attribute to primitive data, right, or any of the other types. We know objects can be passed into functions. We know objects can be assigned to variables. We know strings, arrays, and all those other types. We know they could be assigned to variables. We know that they can be passed into functions as arguments. And we also know that we can return them from function. All right. Those concepts or ideas are not new to us. But then, if you're coming from another programming language, you may find it foreign. All right. That in JavaScript, we can treat functions just the way we treat other data types. All right. So that's why um, it is needful for us to state this fact. Okay, so this is number one thing that you need to understand. But then let's just practically show you this. All right, so um, we have a function. So the first thing we said, functions can be assigned to variables. Okay, so this is a variable. Let's I'm going to call this get name equals function, and then say console.log. So I want to log the name and just say Sam. All right. Now we can simply call this variable because it has a function assigned to it. So this variable is technically a function. So we can simply call that variable and we get Sam printed to the console. So if you see a syntax like this, you should not be taken aback because the function is simply a callable object. All right. So it's a value that can be called. That's what a function is simply. All right. Normally, what you might be used to would be having your functions created like this. All right. This is also valid JavaScript. But then you can assign functions to variables. All right. And you can also assign function calls to variables. So this is a function call, right? Or a function invocation. So I could say let name equals get name. All right. And then we all know that since we are not returning any value from this function, right? If we try to log name at this point, we're going to get undefined. Right? Why do we get undefined? So we're going to get undefined, right? We'll get undefined because simply there's nothing being returned. See, this is the function. This undefined you see here is a function of line 11, not line 7. All right. Line 7 is logging to the console. All right. But line 11 is trying to log the return value from this function to the console. And there's no return value from that function. All right. Hence, we get undefined. Okay. But if we decided to return, all right, return, okay, we decide to return the value Sam, what we'll get now is Sam. All right. So line 11 now print Sam to the console. So when you call a function, that function call will resolve to whatever is returned from the function. All right. So in this case, it will resolve to Sam. Okay, because that's what's returned from the function. And if there's nothing returned from the function, you are going to get undefined. So assuming we have nothing returned from the function, we get undefined. All right. So hopefully that is clear. So functions can be assigned to variables. Either you assign the function declaration to a variable, like you see here, or you assign the function call to a variable, which is effectively the returned value from the function. That's what gets assigned to the variable. All right. So having said that, we'll move to the second item, which says a function can be passed into another function as an argument. So that means simply that you could have another function here, all right, called run function. Okay, funny name, but just explain the concept. Run function, and it expects a function to be passed into it. And what it simply does is to run the function that was passed into it. So take note, the function we passed into it is a function reference, and then when you see these double brackets being attached to a variable name, it means we are attempting to call that variable. So if it's a function, that's going to work. All right. So we're calling the function at this point, any function that is passed into this run function when it's called. So we can go ahead now and say run function. All right, and then we pass in this get name function in it. Okay. So get name function gets to be run. In this case, nothing happens because there's nothing happening inside this get name function. So let's just simply console.log rema, right? And then you see that rema is being logged to the console from line 7. Okay, so now let's check. So what's happening here? What's happening is simply that we call this function, all right, this run function, all right, and then we pass in this get name function to it, all right, and then what happens is that the get name function, all right, gets executed. Okay, so that's simply what is happening here. All right, so a function can be passed into another function as an argument. All right, so in this case, we're passing the get name function into the run function as an argument. Okay, and our code is running quite well. All right, so we have successfully demonstrated the second point. Okay, the last one is that a function can be returned from another function. All right, a function can be returned from another function. So what we could have done simply is to do something like this. So let's say const a equals 12. All right, and then we return the function that is passed into this item. All right, into this function. So instead of just calling it, we just return it. All right. In fact, in this case, we don't even need this. All right. So we're simply doing is just return a function. It doesn't make sense. But this is just to explain this concept in the simplest way possible. So a function can return a function. A function can have a function passed into it. All right. So in this case, if we decide to console.log run function call, and then we'll pass in get name into it, we would see that. So let's check. We would see that run function get name. All right, and we're returning that fn, not fun, fn. All right, so here you see that the get name function, which is what's being passed into the run function, is being returned. All right, so get name function is passed into run function, and then the implementation of the run function simply says return any function that was passed into it as an argument. All right, so in that case, that function is the get name function, and this is it. Okay, so if you check your console, you see that we have that function being returned. All right, so you can return a function from a function just the way you can return any simple value, string, object, any value. In fact, all right, you can also return a function. Okay, so in this case, we could have simply, instead of console login or login to the console, we would have created a new variable and just call it new function. All right, and then we paste this function call. Okay, so what we'll be expecting would actually be this function. All right, so we check, you see that we get a function logged to the console. Or how? All right, recall that whatever you return from a function, okay, so I'm going to rephrase that statement. Recall that a function would resolve to its return value, all right, when it is invoked. Okay, so in this case, run function, all right, is being invoked here. All right, so it's going to resolve to its return value. And what's the return value of run function? The return value is simply the function that gets passed into it as an argument during its execution. And in that case, that function is the get name function. All right, so this run function is going to resolve to the get name function. Okay, so I know I've been making use of the term function. All right, but if you slow down a bit and rewind the video, if there's any need to do that, you'll get more understanding of what I'm trying to explain. All right. Okay, so I've simply explained these points. All right, all these points. The function can be assigned to variables. Functions can be passed into another function as an argument, and a function can be returned from another function. All right, so now let's go into the concept of closures. Okay, and again, before we even do that, there's another concept that you need to be aware of. Okay, so let's talk about our concepts. That's number 2. All right, the concept of higher order functions. All right, so this is simple. I've already touched on it during the first point. Okay, so higher order functions are functions that receive another function as an argument or return a function. Okay, so just as a way of recap, we'll do get name. Okay, and then get name is a function at this point, a normal function. All right, at this point, because it's just a simple function. Okay, so this is get name. Well, how can we convert get name to a higher order function? All right, to convert get name to a higher order function, get name has to either receive a function as an argument, all right, or return a function. Okay, so if you have a function that receives a function as an argument or returns a function, so it could do either or both, receive a function as an argument or return a function or both. All right, so it could also receive and return. All right, if either of these happens, okay, that means that function is a higher order function. All right, so let's see some examples of higher order functions in JavaScript. Okay, so number one will be the set timeout that I'll be making use of. All right, set timeout is a function that receives a function. So the first thing it receives is a function, which is a callback. Okay, and then the second is a regular value, all right, for the timer. Okay, so this is a higher order function simply because during its invocation, it expects a function to be passed into it as an argument. All right, so that's the timer for you. And then there is promise. All right, so there is the concept of promises. So let's call this my promise equals to new promise. All right, and then a promise expects a callback, all right, which is called the executor. All right, it expects a callback. So you could pass that callback into it as a reference or directly like this. All right, so it expects a callback, and then that callback is going to get resolve and reject. So this is a promise for you. All right, but then let's be focused on why we're even talking about promise. Well, a promise at this point. All right, I'm simply saying that a promise is a higher order function because it expects a function to be passed into it during its call. All right, so there are other um, constructs or other types of functions in JavaScript that are higher order functions. All right, and you can also create your own higher order function. You just simply create a function that um, requires a function to be passed into it or returns a function. All right, so we've simply created our own higher order function called get name. Okay, so having explained these two concepts, let's now go into the concept of closures. All right, so I've explained closures during the last video. A closure is simply a closure is simply created when a child function holds a reference to the resources or any resource in the parent function. All right, so a child function that is being returned from that parent function holds reference to the resource or resources that are created, all right, or that belongs to the parent function. Okay, so what we did during the last class was we had function and we call this parent, and then we returned a function from it, all right, and the function we returned, you can make it anonymous or not. Anonymous means without a name, all right. The function we returned, so let's say we have a resource called age in this case, and then we're going to return a function, and the function we return is going to hold a reference to the resource that belongs to the parent. Okay, we have simply created a closure, all right, at this point. Okay, so a closure is created when the child, all right, or the return value from the function holds reference to the resource available to the parent function. All right, so that is simply the concept of closures. All right, for a more in-depth explanation of what a closure is, I think you should see the previous class. So I'm trying to reduce, or I'm trying to avoid the temptation of re-explaining what I had explained during the last video. So this video is supposed to be about practical implementations, all right, practical scenarios where you would need the concept of closures. Okay, all right, so let's get into that. So imagine that um, I have a function which does a very heavy task, all right, a very heavy calculation. Okay, when I mean heavy, I mean a calculation that takes time and memory. All right, and then I'm thinking of how to optimize that function. So let's write the function. So let's say function multiply um, by 2. All right, multiply by 2 is a function, okay, that takes a number and then multiply the number by 2. This is not a very heavy operation. I'm trying to make our implementation as simple as possible. So we have a function, a normal function that takes in a number and multiplies the number by 2. But let's assume that before the result is returned, we're going to have a heavy operation go on here. Okay, so a heavy operation is going to take place, and then before the result is returned. So we call this multiply by 2 function, and then pass 2 to it. Okay, what we get is 4 returned to the console. So let's log it to the console. All right, so we get 4. Okay, now if I call this function another time and pass 2, we get 4. All right, so at line 7, 4 is printed, at line 8, 4 is printed. You might not see anything wrong with this um, code that we've written. Okay, but I'm going to show you why there could be something wrong. All right, so assuming that a heavy operation happens here, do not forget. Okay, if we call multiply by 2, that heavy operation is going to take place before our result is returned. And if we call multiply by 2 again, that heavy operation is going to take place again, and then our result is returned. So how can we avoid this heavy operation happening every time? All right, or let's even assume that this is the heavy operation. So just think of it as this is something difficult that takes time to return. All right, so how do we want to avoid a scenario where every time we call this function, even though we are passing in the same argument, we still have to repeat the operation? All right, remember that this is a heavy operation. We have to repeat this heavy operation every time we pass, every time we call the function. All right, irrespective of what the argument is. Okay, so how can we prevent that? So we could use the concept of closures. So I'm going to do something. I'm going to create a cache. All right, and that cache will be an object. Okay, and then instead of returning my result, I'm going to return a function. Okay, and that function is going to do something. The function is going to check if, all right, we have in the cache num. All right, so whatever number you pass in, our function being returned is first going to check if that number that you have passed in exists in the cache. And if it does, all right, if this condition returns true, we're simply going to return the value of that number in the cache. All right, but if it doesn't exist in the cache, all right, what we're going to do is we're going to carry out the operation. Okay, so I'm going to say let result equals num times 2, and then we're going to add result to the cache. So I'm going to cache cache num equals to result, and then I return result. All right, so what have we done? What I've simply done is that we have created a memory. So a cache is simply memory. All right, so I've created a memory to recall every operation that we're going to make. All right, so if I call this function, all right, it's going to return a function for us. In fact, let's take num and put num here. All right, so if I call this function, it's going to return a function for us. So this is like a factory function, if I can use that word now. What it simply does for us is to create this environment. That's what we simply want from it. All right, to create this environment and then return this function for us. Now this function now has access to this cache because of the concept of closure. All right, and what happens is that when this function is called, we would first check if we have a result for the operation in the cache, and if we do, simply return that result. But if we don't, we go ahead and carry out the operation. All right, save the return value of the operation into the result variable, and then we're going to put that result in the cache, which is the memory, so that in case we do this another time with the same number, it's going to exist in memory, and then we're going to simply return without carrying out this operation. All right, so what I'm going to do is let's put a console log here and say returning from cache, and then here we'll put a console log and say performing a fresh operation. All right, so that we know when it's performing a fresh operation and when it's returning from cache. So I'll come down here, this is multiply by 2, and then create a variable called multiply by 2 factory, and then multiply by 2, just to call multiply by 2 function. All right, so when we call this function, remember it returns a function. This multiply by 2 returns a function, and this function is what we actually need. All right, so here it returns a function, and that function is assigned to this variable. Remember the concepts that we explained earlier. All right, and then we can simply call this variable because this is a function. All right, so what we do now is to simply call this variable twice, and let's see what happens. So if we go to the console, you see that we're performing a fresh operation the first time that we call that function using 4 as the argument. That's the first time here. But the second time we attempt to call that function using the same argument that we've used before, all right, our function is going to remember that we have done that operation before using the same argument. So there's no need to perform the operation, right? So what we simply do is we go straight into the cache, we get the result, and we return it to the user. And that's what's happening here, returning from cache. Okay, so if I call this 6 times, we'll only perform that difficult operation once. Then for the subsequent calls, all right, with the same argument, we don't need to perform it again. We simply go directly into the cache and get the result. So you see, the first time we do performing a fresh operation, and then from the second time downward, we keep returning from cache. All right. If I try to call this function again using a new argument 6, all right, because we do not have 6 in cache, all right, we've not performed any operation with 6 before, what we get is performing a fresh operation and we get 12. All right. And if I repeat this operation again, we should be getting it from cache. We shouldn't be performing the operation again. So we get it from cache, returning from cache, because it has been performed before. All right. So now the benefit of closures in this example that I've given to us is that closures help us to remember values. All right. So we can remember values. We can hold on to values in an enclosing scope and then take advantage of it. In this case, we create a value in the enclosing scope and call it cache. All right. And then what we simply do is we store the result from fresh operations in the cache. And then anytime this function is called, we'll first check the cache if that operation has a result in the cache. All right. And if it does, we simply return it from the cache. If it doesn't, we go ahead and perform a fresh operation, get the result, assign the result to cache, return the result. All right. We assign the result to cache because we want to be able to return that result from cache if in the future somebody tries to perform an operation with this function using the same argument. So we know that the result is sure to be the same as something that we've done before. So instead of re, um, re redoing the operation or perform the operation afresh, we simply get it from cache. Okay. So I am aware that this could be a lot to take in, but it is what it is. So we just need to take time, sit down, understand what's being said, and it's going to make more sense with time. All right. So I'm going to give us another use case for closures. All right, another use case for closures. Now, before I do that, I must say that this could be an interview question. All right, this could be an interview question. Okay, I think I can attempt to formulate a question. All right, I can attempt to formulate a question from this. So let's try to formulate that question. So I'm going to say question. All right, write a function that returns a function, all right, which accepts a number, right, and multiplies that number by 2, right? So write a function, let's say, which returns a function that accepts a number, multiplies that number by 2, and returns the result. Okay, that would have been very easy. But then this is the part that requires the concept of closures. All right, so say if the number passed into it is repeated, all right, the function should recall that or recall the result from that operation and return that result instead of carrying out a fresh calculation. All right, so we can leave it at that. So this is the part that could get people confused. All right, it could throw you off. So this first part is pretty easy. We could have done this with a normal function. We don't need closures. Write a function which returns a function that accepts a number, multiplies the number by 2, and returns the result. Very simple. All right. But then this is the catch. It says if the number passed into it is repeated, all right, that means if we repeat the number passed into the function that we're creating, all right, the function should recall the result from that operation, all right, and return that result instead of carrying out a fresh calculation. So this is a very rough question, just trying to bring up something, all right, but this is something that you could well see in an interview, all right, question. Okay, algorithms. So closures, or the concept of closure, is something that you can use to solve this. All right, so this is caching. You should read about the concept of caching. This is an actual concept. Okay, and when we get to React, we're going to okay, this is for backend developers. All right, but if you happen to be somebody who does front end, when we talk about memoization, if I spelled it right, all right, it has to do with this concept of caching. All right, so closures are a very, very, very important concept in JavaScript. So let's try to apply closures, all right, using another entirely different scenario. Okay, so let's assume that we want to create a module. Okay, we want to create a module. So I'm going to get rid of this code. Let's assume we want to create a module. In fact, this time let's formulate a question and try to answer it. All right, so I say question. Assuming we want to create a module which hides its implementation, right, from users, but only exposes some functionality, right? How would you mm, create that module? Okay, using the concept of closures. Okay, so how do we do that? So what we can do is simply write a function. So assume we want to create a module that hides its implementation from users, but only exposes some functionality. So let's do this. Function, let's call it module func. All right, so that's the name of our function for lack of a better name. And then this module is going to have some inner implementations. So we're going to call this count equals to 0. Okay, this is oversimplified. All right, you should know that this is oversimplified. Okay, but the implementation could be anything. All right, so we have this implementation in our function, just a variable like this. All right, but we do not want anybody from the outside world to be able um to change this value. All right, we want to control how this value should be changed and assessed. So what can we do? We can simply create functions, right, and call this get count and then return count, right? We can write another function and call it increment count, right? And that does count plus plus. We can write another function that says reduce count, right? And count minus minus, all right? And then we can simply do something. So what we do is we return an object that has access to get count, has access to increment count, and has access to reduce count. Okay. So what we're doing now is that we are controlling how count um, can be manipulated. All right. So in this case, if I bring module here, so we can make a call to module. I want to create a module. So I'm going to call it module one. So let's say let module one equals module func. And I've created that module. All right. So what we can do here is simply let's console the log get count. Remember, get count is going to return count. All right. So if we want to see count, we have to say module one dot get count. All right, and just call it, and then we'll see that count is 0. Okay. So let's increment count. To increment count, I will simply say module one dot increment count and just call it. And we have incremented count. So let's console log the value of count. So let's get count again. We try to get count. So get count. Count should now be, so let's try. Let's see. Module one dot increment count. Count plus plus. So I think I might know what's going on here. So there's an error. Let's check. So assignment to constant variable. Oh, I see. So we're going to use let, all right, because we ought to be able to change that. Okay. So if we come back here, we see that count is 1 at this point and count is 1 at this point. All right. So let's get rid of this. Okay. So if I increment count twice, we should expect count to be 2 here. All right. So at this point, count is 2. Okay. So we get count is 0 initially, and then we increment count twice, and then try to get count again, and count is 2. So you could see that we have access to this variable because of the concept of closure. We have constant access to this variable at any time. All right. So we have access to its current state at any time. So we could even decide to decrement count. So let's decrement count or reduce count, and then let's check what count could be, value of count. All right. So you see that after we reduce count, it became 1. All right. So count was 0, and then we increased it twice, we get 2. So we console log it, we'll see 2. And then we'll reduce it once and try to get the current value of count, we get 1. All right. So we can get access to this variable like this. All right. But here is the catch. Apart from these functions that were exposed to us, we cannot do any other thing with count. All right. There's no other thing we can do with count. Okay. We can only affect count using the things that were returned to us. All right. So this is the concept of modules. And when we get into modules, all right, you would see how this makes sense. Okay. So we can actually implement that concept. There's a way to do it in JavaScript, another way to do it in JavaScript. But we can use the concept of closures, okay, to actually implement modules. All right. This might not make sense now, but just understand what's happening in the code. Ensure that you understand what's happening in the code. And then as we progress, a lot of these things are going to come to light. All right. I know that for some of you watching this, it already makes sense to you because you have some level of experience with modules, so you know what I'm talking about. All right, but for those of us who do not, some of these concepts are like that. You just need to understand what is being explained per time, all right? And then when you get to that level or somewhere in the future, everything is just going to come together. That's how programming works. Okay, so this is encapsulation with the concept of closures. Encapsulation because you don't even know how get count is going to get the value of count. You just know that there's something called get count, and that's what's available to you. You don't even know the inner implementation or the inner workings of increment count. All right, you just know that when you call it, it increments count. Okay, and apart from these things that return to you, you cannot do anything to count. All right, you can only do as much as is exposed to you, right, through the return statement. Now, before we call it a day for today's class, you should take note that we are returning an object, but then the concept of closure still applies. But we're actually returning an object, but then concept of closure still applies. Why? The reason is because whatever we are returning still holds a reference to, right, resources that are available in the enclosing scope. Okay, so anytime you have reference or a reference to an enclosing scope, a closure is going to be created. All right, and this is going to make sense with time. So this is what we call it a wrap for this session. Okay, so see you in the next class.